energy efficiency versus air quality, and the trade-off in Indian cities. Just to give you big picture stuff, me being an MEP consultant, I would try to take a step back and try to view the mechanical, electrical, and plumbing systems as a whole and how it corresponds with the air quality, and discuss about some of the topics that I have encountered in the past, the strategies that I have applied in the past that have worked well for me. So to dive first of all into the topic, let's try to check what causes basically the air quality to deteriorate, which can be directly related to building systems. And by building systems, we'll still try to narrow down onto the HVAC systems, because HVAC systems, if you try to read a energy modeling report, tend to end up using the most operational energy out of the utility systems that come into picture. First and foremost, I think so this aligns with what Nairji mentioned when he gave the example of high filter versus low filter. Try not to over design HVAC systems. This is one of the main topic that comes into picture when consultants try to argue with the commissioning agents with the sizing of the HVAC equipment. Just because your heat load calculation says you need a 175 tons of refrigeration system does not mean you need a 175 tons of refrigeration system all the time in a given year, right? The next one is, I think, something that is aptly mentioned by Deepak ji in his talk regarding the proper utilization of the new technology. Sit down with the experts, be it the manufacturers, be it the vendors, be it the commissioning agents. Lack of knowledge and experience in new technology is where a lot of slips happen that eventually relate and correlate into the air quality being deteriorated in the broader sense. One thing is to design the systems, but it's whole another topic when we try to run these systems, the HVAC systems, electrical systems, or plumbing systems. The trained manpower that is going to be handling these building systems is also very critical to ensure that the long-term effects of all of these building systems is reduced when we track the global footprint for the carbon. And last but not the least, there are quite a lot of government incentives to ensure that we get as close to being 100% efficient. Of course, we are never going to be 100% efficient, but we are trying to make leaps before it. And that is where the government incentives come into picture for increasing the energy efficiency as well as the reduction in carbon emissions. Some strategies that have come in handy and tried and tested on bulk of my projects, I would say, to ensure that we get the project to be either net zero carbon, net zero operational carbon, or try to make a qualitative step towards the decarbonization of the project. First and foremost, I think this was one of the point on Deepak G's slide as well. Ensure that the systems that are being designed are optimized. Again, do not oversize the services equipment. Try to have the experience of the HVAC consultant count towards reducing and optimizing the size of specifically the HVAC equipment. Again, just because your heat load says you need a 175 tons of refrigeration does not mean that you need to go a 175 tons of refrigeration. Properly ensure that you are doing your energy modeling analysis backed by the data before making the equipment finalization in the design stage of the project. So ensure that this important point is being done, because the more you try to predict the energy efficiency on the given system, the more you will ensure that you reduce not just your cost, but also the carbon emissions from the given HVAC systems or any building systems that you're trying to design in the design stage. Next, this is a topic that has been discussed and currently quite rigorously applied in many of the developed nations is the electrification of building systems. One of the key aspects that has been introduced, as per my knowledge, in the state of California, which tends to be energy efficient and code setting standards for the rest of the world, is making sure that the commercial kitchens, where you end up using a lot of natural gas or LPG to cook your food, try to make it electric. And that is what an incentive and a joint approach by the government as well as the stakeholders come into picture. So it is a joint effort, I would say. One more energy efficient system that I have gotten good use out of is the heat pump water heaters. Try not to use a direct resistant type water heater, or be it on the gas or fossil fuel burning water heaters. Try to ensure that your buildings are as electrified as possible, to make sure that you try to get as close to the net zero carbon on site that we are talking about. Next is try to rely on the energy recovery strategies. These might be Some of these might be economizer mode in AHUs, fixed plate heat exchangers, enthalpy wheels in AHUs, as well as water to water heat recovery. These are just some of the strategies that end up helping the project consume less and less fossil fuel or energy, be it from the utility or be it on site production, to ensure that the big picture stuff, when we are talking about air quality, we are just not talking about the project. We are not just talking about the state, the country, but the entire world, because borders are human drawn borders, right? The environment doesn't have any borders. So whatever is done by us also affects our neighbors, and whatever they are doing also affects us. So big picture stuff, ensure that energy recovery strategies that don't cost too much upfront can also be accommodated in the projects that get designed. Next is something that one of our panelists, who is an expert in IoT, might also vouch to it, is operating the systems in tandem. Try not to have your ceiling fans work separately with your HVAC system. Try to link them with smart controls. Try to ensure that the proper comfort levels are met, and not the HVAC systems running overtime just to meet the requirements. Sometimes it might be that the ceiling fans might run enough to ensure that the HVAC systems don't run in the same place as well. Daylighting control, artificial lighting levels is also one of the major things that needs to be taken into consideration, because after the cooling, heating, it's the lighting levels that end up using a lot of energy in a given project, in a given typical project, I would say. And last but not the least, work out with the entire team, because we as engineers or manufacturers or the vendors are not just working in silos. We are working in a team. We are working towards the good of the project. So that also includes the other stakeholders, be it the architects, be it the other engineers, structural engineers, civil engineers, the owners, of course, as well as any shareholders in the projects as well. Try to work with them to ensure that the project that we are designing is climate responsive. What does that mean? In India, we have the chhajjas. That is a form of climate responsive design, that when the sun goes overhead, you don't have the direct sun rays coming to the room. Just an example of a climate responsive design. So work out with the other stakeholders. It is a joint collaborative effort that we are trying to put in together to not just increase the energy efficiency, but also increase the quality of the air that we breathe in. So with that, I will part from my presentation and hand it over to the hosts. Thank you.